Homework help for 4-1. Question 1. State the degree and leading coefficient. 5x to the 4th plus x cubed minus 7. So the degree is here. The degree is 4, which makes the leading coefficient 5. Number 2, same question. We have 14y plus 3. Ooh, I put a minus or plus on that. I apologize. Let's go ahead and call that minus y squared. I'm choosing to call that minus y squared. I apologize. So here, our degree is the highest exponent, so there's our degree. Which means our leading coefficient is what's right in front of that. So just so we're aware why I put this question on here, our leading coefficient is -1. Okay. Number 3, so we've got this equation, x to the 4th minus 13x squared plus 12x equals 0. We're to determine whether each is a root. So number 3 is asking, is 0 a root? I put a question mark there. Is 0 a root? So we're doing 0 to the 4th minus 13, 0 squared plus 12 times 0. Does that equal 0? And of course the answer is 0 minus 0 plus 0 equals 0. Yes, it does. And we're simply going to do that for 4, 5, and 6. So is -1 a root? So that's -1 to the 4th. Watch, make sure you put that in parentheses. Minus 13 times -1 squared plus 12 times -1. And does that equal 0 is the question. So here we'd have 1 minus 13 times 1 minus 12 equals 0. Still a question. And mathematically, normally actually, if we're trying to answer that question, the question mark goes over the equal sign. Does that equal 0? 1 minus 13 minus 12, and that's a big fat no. Number 5 is 1 work? So we have 1 to the 4th minus 13 times 1 squared plus 12 times 1 equals 0. 1 minus 13 plus 12 equals 0. And that does, because we get -12 plus 12. That's a yes. 6 is -4 a root? We have -4 to the 4th minus 13 times -4 squared plus 12 times -4. And does that equal 0? So we get -4 to the 4th, which is going to be 256, minus 13 times 16, minus 48. And does that equal 0? So we have 256 minus 13 times 16. We have 160 plus 48 minus 208. Minus 48 equals 0. And yes, that checks out. So it looks like 3 was yes, 4 was no, and 5 and 6 are both yes. 7. Is x cubed plus 3x plus square root 5 a polynomial in one variable? Why or why not? Yes! Yes, it's a polynomial in one variable. Why? Because there's only one variable. X is the only variable. And remembering the definition of a polynomial, all of my exponents on X are positive integers. Because we have the 3, a 1, and then that doesn't even have an X on it, so we're good. Doesn't care, does not matter that square root 5 is irrational, because it's not, doesn't matter. That's a coefficient, and my coefficients can be anything. Write a polynomial of least degree. So question 8, we have -2 and 3 are my roots. I'm going to Jada skip it to, that makes x plus 2 times x minus 3 equals 0. Distribute. X squared minus 3x plus 2x minus 6 equals 0. Combine like terms, x squared minus x minus 6 equals 0. Okay, done. That's the polynomial of least degree for number 8. Number 9, threw this in here because you guys might see a decimal and get scared. Jump. We're going to do x plus 2, x plus 0.5, x minus 4 equals 0. Pick 2. I'm going to pick the right 2 because I can. So the x plus 2 is going to stay. This is going to be x squared minus 4x plus 0.5x minus 2 equals 0. Actually, you know what, guys? I'm going to show you a different way to work this because it's important for once we decide to start working with a couple of other... Boy, it keeps on missing it. We're actually not going to skip ahead. So we have x equals -2, x equals -0.5, and x equals 4. Let's assume for a second I don't want to work with that decimal. How do I get rid of 0.5? I'm simply going to multiply both sides by 2. So now I've got x equals -2, 2x equals -1, and x equals 4. So now I've got x plus 2 equals 0. 2x plus 1 equals 0. X minus 4 equals 0. Now, no decimals. Oh. I'm still going to distribute on the right. So 2x times x is 2x squared. 2x times -4 is -8x plus x minus 4. Combine like terms. That's still x plus 2. 2x squared minus 7x minus 4. And one last distribution. 2x cubed minus 7x squared minus 4x plus 4x squared minus 14x minus 8 equals 0. It's an ugly squared. My apologies. Combine like terms, I get 2x cubed. We have negative 7x squared and positive 4x squared makes negative 3x squared. Negative 4x and negative 14x makes negative 18x minus 8 equals 0. There's my polynomial of least degree for number 9. So that's what we do when we have a decimal. It's the same thing that we'd do if we had a fraction for a root. Number 10. My roots are plus or minus 5i and plus or minus I. This one I can jump. So I'm going to say x plus 5I times x minus 5I times x plus I times x minus I. So we've got these conjugate pairs again, so we're not going to have a middle term. So we have x squared minus 25I squared. We have x squared minus I squared. I squared, of course, is -1. Don't forget it. So that's going to turn into x squared plus 25 times x squared plus 1. And now I distribute. X to the 4th plus x squared plus 25x squared plus 25. We have x to the 4th plus 26x squared plus 25 equals 0. There's number 10. 11 through 14, I didn't give you a lot of examples like this in class, but we should know how to graph. And roots are where the function crosses the x-axis. So if we have x plus 8 equals 0, x equals -8 is the one root. Now we could have also got there with one root here because the exponent on that x is a 1. So there is one root, and it is -8, and x equals -8 is a vertical line through -8. So I'll call that -8, and I'll draw a line through it. Our factoring skills, guys. 12 through 14 are supposed to test our factoring skills and whether or not you've retained them, or if so, how much have you retained them. So number 12, we have x cubed plus 2x squared minus 4x minus 8 equals 0. So state the number of complex roots. Number of complex roots, 3. It's the highest exponent. Find the roots and graph. So find the roots and graph. We have 4 terms, and there's nothing I can factor out of any one. So we're going to have to factor by grouping. So we take the first 2. This is a method, and it doesn't always work this way. And we're going to box off the second 2. So if I look at the first 2, what can I factor out of both of them? I can factor out x squared. If I factor an x squared out of the first 2 terms, the first term would be left with an x. The second term will just be 2. What could I factor out of the second 2 terms? The second 2 terms, I can factor out a -4. If I factor -4 out of the first of the second 2 terms, I only have x. And when I factor -4 out of the second, I have +2. And I want those to match. So now out of this first term and this second term, I can factor out x plus 2. If I factor x plus 2 out of the first term, I get x squared. If I factor x plus 2 out of the second term, I get -4. That second parentheses can be factored. That's x plus 2 times x plus 2 times x minus 2 equals 0. So what are my 3 roots? My 3 roots are 2 and -2, but -2 occurs twice. So we have multiplicity 2. Which we'll learn later means that it's going to act like a parabola at 2. So for now, this is just an intro, and hopefully you guys tried this on your own and maybe tried graphing it, maybe threw it on Desmos. And remember, it's a sketch. We're not going to worry about whether or not my maximums or minimums are crazy close to what they should be. I just know I'm crossing through 2, and I'm crossing through -2. But -2, if you don't recall, makes kind of a bounce point because of that multiplicity 2. It's a cubic function, which means and it's a positive cubic function, which means it ends high and started low. So I'm going to go up to that point, I'm going to bounce off it, then I got to come back, and I got to head up. That was ugly. Bounce off, come back, head up. There we go. Add a little point of inflection there that shouldn't have been there. Now we can actually see an error in my graph right off the bat. Because if I plug in 0 to my original graph, I'd actually get negative 8. So that's actually bothering me. If I plug in 0 to this graph, then it's going to equal negative 8. So I'm actually going to go through 1, 2, 3, 4, 5, 6. I'm actually going to go through that point right there. So there's like an extreme dip to get there. That's close enough for a little sketch. 13. I'm going to show you guys a trick. 13 and 14 are both on there for a reason. I choose my questions carefully because I want to introduce you to certain concepts if you've missed them. We have x to the fourth plus x squared minus 2 equals 0. Now, if you have a trinomial like this, and the first term is to the fourth power and the second term is squared, or actually whenever the exponent on the first term is double the exponent on the middle term, which is, and then the last term is 0, x to the 0, you can still factor it by thinking what multiplies a negative 2 and adds to 1. So I can still do my double bubble factoring. What multiplies a negative 2? Well, that's only a 2 and a 1. But I want the 2 to be positive and the 1 to be negative. And now these are both x squareds. Instead of x minus 1 times x plus 2, it's x squared minus 1 times x squared plus 2. And that's going to give me all 4 of my roots. By the way, you should know there are 4 roots. So x squared minus 1 equals 0. X squared plus 2 equals 0. So x squared is equal to 1. X is equal to plus or minus 1 when I square root both sides. X squared is equal to 2, which means x is equal to plus or minus after I square root both sides. Sorry, x is not equal to just 2, is it? I missed that. X is equal to negative 2. If I square root both sides, then x is equal to plus or minus I square root 2. How do I graph that, right? So when you have an imaginary or complex root like this, what that means is that it doesn't cross the x-axis. It does not cross the x-axis. So the only place that this graph is going to cross the x-axis is at positive 1 and at negative 1. It's an even function, and it's a positive even. So it starts high, ends high. Square root 2 is after 1 and negative 1. So after 1 and negative 1, I'm going to do a little bit of a wiggle. So I know that I'm going to cross through these. And it goes through negative 2, so it's actually a pretty steep U. And then instead of keeping on going, I'm going to need to wiggle just a little bit. Nah. I don't know if I care for this graph. But I've got an idea. I've got an idea of what's going on. Might not be perfect, but it's an idea. I almost want to plug this one into Desmos really quick just to see. X to the fourth plus x squared minus 2. Let's do it. Let's see how far off I am. Now, I'm not talking points. I'm just talking about... Let's see here. We've got x to the fourth plus x squared minus 2. Well, that's equals y, if I want to get it accurate on Desmos. So there it is. It actually doesn't wiggle as much as I think it does, if at all. It'll take some calculus to see whether or not there is a point of inflection anywhere on this. It looks fairly parabolic. Oh well. Nothing in my graph said I was wrong. And I didn't want to pull in additional skills beyond what's in this class at the moment to get a perfect graph. So, the amount that I made it curve was excessive. I'm still going to argue there's a little bit of a point of inflection somewhere. It's just beyond my eyes to see. So, last one is 14. We have 4x to the fourth. So we know there are 4 roots because that is the highest exponent, 17x squared plus 4 equals 0. Once again, we're going to factor this. The only things that multiply to 4 are 2 and 2 or 4 and 1. And so we're going to stick with 4 and 1 and 4 and 1. I'm going to do 4x and x, and I'm going to do 4 and 1, and I'm going to do plus, and these need to be squared. Now, when it comes down to you guys factoring it, you guys either have your Xbox method or your own method of factoring, and you need to be able to get there on your own. Okay, but we can tell that when I distribute this back out, that makes 4x to the fourth. Then we have 16x squared and 1x squared. That makes our 17x squared. And 1 times 4 makes 4. So, set each of these equal to 0. Subtract 1. Subtract 4. Divide by 4. And square root, square root, square root, square root. X equals plus or minus 2i, and x equals plus or minus 1/2 I. Because the square root of 1 is 1 and the square root of 4 is 2. So we have the square root of 1/4 is 1/2. So this one never, it's got 4 roots. We've got all 4, positive 2i, negative 2i, positive 1/2 I, negative 1/2 I, but at no point does this graph cross the x-axis. So it's just going to float above, it's facing up, it's a positive, even function. So, and it goes through 4. And we take a guess. We take a guess at what it looks like because we don't have the skills in our toolbox yet to figure out exactly what it looks like. So we know it ends high on both sides because it's a positive, even function. And now I'm all scared of myself on whether or not I will actually make it wiggle at all. So I won't. Close enough. Close enough. Now I'm going to see whether or not it did. Now there could be points of inflection, right, on either side, just like the last one. 4x to the fourth, 17x squared. Let's go ahead and get it in here. 4, 17, and 4. So it's much thinner. It's much thinner, but hey, I still can't see the wiggle, so I'm good with my graph. I'm good. It just could have been, well, I'm saying I'm good, but then at the same time I'm erasing it. I knew it ended high on both sides, so whatever. There we go, guys. That's your homework. Hopefully you guys got through most of them on your own. See you tomorrow.